Very good afternoon to you, sir. So today we would like to present our lab 6. So I would like to share my screen. So this is our lab 6, Ohm's law using multisim simulation. So the main objective to do this lab sheet is to investigate the relationship between the voltage, current intensity, and also the resistance. So it's easy to use the multisim simulation, so we can get the current values easily. While that okay, so for the table 1, we should calculate the current intensity using different types of voltages. So if we use the formula, we should get the same answer as the theoretical values as well. So something like this. So the intensity measure is the value from the multisim simulation, while the current intensity theoretical is from the formula. So we should get the same value for the current intensity using the simulation and also the using the formula. So that's for resistance. When the resistance is the same, but the voltage increases and the current also increases. So current is directly proportional to the voltage. While table 2 is where the voltage is the same for everything, but the resistance is different. So as same as the table 1, we should get the same value for using the formula and also the using the simulation. So as you see here, we got the same values for the formula and also using the simulation. It's almost the same. Maybe some decimal places it's quite different, but it's the same value. When the resistance are high, the current will decrease. So that is what we got from this lab. While as you see the questions, you also explain about the current versus voltage, so which is directly proportional to the voltage. Current is directly proportional to the voltage, while current decreases when the resistance increases. That's what we learned from this lab sheet as well, which is so called current is inversely proportional to the resistance. So you can see the graph. This is current, this is voltage. It's increasing, so which is directly proportional, while this is resistance, this is current intensity, which is decreasing linearly, so it's inversely proportional. So this is what we got from the lab. While that, I would like to show our simulations as well. Okay, so this is the simulation what we did actually, and when you run, we will get the values from the current prop, while we can change the voltage value here and also the resistance value here. So we just can change from here, can change here also. If you change, can calculate the current intensity. From this example, I'm changing to 10 watt, so the current is different. When you change the resistance, let's say it's 100 ohm, the current changes as well. So this is how we should use the multisim simulation. That's all, sir. Thank you. So another part my partner will present.
Assalamualaikum warahmatullahi wabarakatuh. So today I'm Putra will be presenting for the second part of this lab. So in this lab, we are required to use the same circuit but with different values of resistor. So the values that we are going to get, we can tabulate the data in table 2 here. So in this part, we have to use the same values of voltage throughout the part, which is 5 volt, and different values of resistance. So if we look at this circuit, if we use the 5 volt, and we can change it here for the resistor. Sorry. And if we run the simulation, we will get the current value here. And if we can change the resistance, the different values of resistance, and we will get the different values of current, and we can tabulate the data in table 2 here. So for the question, we will know that what will happen to the current if the resistance double, then fold, and etc. The current will be decreased. So the relationship between current and resistance is that current is inversely proportional to the resistance. So if we can use the data and make it a graph, we can see that the graph is inversely proportional. In conclusion, the data shows that the higher the voltage, the higher the current, meaning that the voltage is directly proportional to the current, which is what Ohm's law states. This means when the voltage increases, the current will always increase as long as there is no resistance or if the resistance stays the same. For example, in my experiment, I increased the voltage from 3 volt, 6 volt, 9 volt to 12 volt, while keeping the resistance the same to the current increase every time the voltage increased. The law was proven for every trial I performed, and can be shown when dividing the voltage by the current to get the resistance, as shown above. The voltage is directly proportional to the current. Ohm's law deals with the relationship between voltage and current in an ideal conductor. This relationship states that the potential difference, which is voltage, across an ideal conductor is proportional to the current through it. The constant of proportionality is called the resistance. This can be expressed in an equation as V is equal to IR and can be manipulated to find the other two variables, I and R. The point of graphing this lab experiment was to establish the relationship between current and voltage in part 1 and the relationship between current and resistance in part 2. So the objective of this lab was achieved, which is we were able to investigate the relationship between voltage, current intensity, and resistance. So that's all from us. Thank you.